Okay, I've already shared, and we're going to see the Bayes algorithm, how the mathematical formulation is and how it works. On a smaller data set, I'll be taking that. So let's have it now. Okay, let's just put the things. Okay, so this is a supervised learning classifier, and what we do here, there are three, four steps which are important. First, it calculates the prior probability of any given data set. Whatever the data set you have, it finds the probability of the class it may belong to, the data may or the row. So data here, when we say data, actually it is each row, and then on the right hand side we have the class when we are talking about the supervised learning. So which data belongs to which class, it tries to find out the prior probability first, then likelihood probability, it finds what is likely that it would be the same. It the attribute matches the class, the features, attributes, whatever you can call that. Features are actually, it is actually the data which is, like, suppose if we are taking uh, talking about cancer, size of the cancer, type of the cancer, that would be the feature. Okay, so similarly, if you're talking about leaves, then again, color, size, shape, length, that will be the feature. So depending on the class you're talking about, the features may vary, and they can be of any numbers. So they are not limited by numbers. So features can be 100, 200, depends. Time series data also we have. In that case, suppose you're looking at the traffic at what of a month in a particular area, what is the uh, you can say pattern. Yeah, what is the pattern of traffic in a particular area? So if you see it hourly in one day, that is for 24 hours, you have one time series data, and for a month it will be more, like what we have, 24 into 30. So these will be the features which will be passed on for a particular day. That will be the year class. So features may vary. Okay, so features depends on the amount of data it has, a particular entity or a particular class has. Okay, or label also. In transformers and all, we call them labels. Their classes, basically which class it belongs to. So we may call it label, or entity, or a class. More specifically, it is a class, right? Okay, so two things. Now, third is the Bayes formula. It has to be put into the Bayes formula. Formula is written down, and then we have to see that which class has a higher probability, and we retain that, and we just chop out or leave the others or drop it out. So that we don't have to do it. The formula, the algorithm will do it itself. So this is the formula. You have the probability piece, the probability here. Okay, so it tells us how often A happens given that B happens. So if B happens, then what is the probability of A happening? Okay, so it is written as PAB, also called posterior probability. It is also called posterior probability when we know how often B happens given that A happens. Okay, how many times B happens given that A happens, right? So according to that, you can see that probability of B occurrence, probability of B occurrence when A has already occurred, and what is the probability of A occurring. You multiply that, divided by the probability of B occurring, and you get that this is your Bayes probability equation. Okay, now formulation also you can say that very simple, but we have to see how it works. So we have taken a very small example. When I've taken rather a very small example which is already there. I found it somewhere. I found it to be interesting actually. Otherwise, if I take big data, then it will be little difficult to understand. So first thing is get the data. So let me put the data here. These are just the lists. So we have okay. So the data. So let's see. Suppose we have weather, temperature, and claim. This is the label, or you can say the class, and this is the data. Now the data is something like this: that weather is sunny and hot, then you can play or not. No, okay. And sunny, hot, there is no sunny and hot again. There's yes in some case, and overcast, mild, yes, and so on. It is something like this. Okay? So you can always modify, change. You think that sunny and hot should not be allowed at all, then okay, you can remove that. You can say, okay, fine, no. So it depends on me how I want to handle that, right? One, okay. Hmm. Let me. Okay. Yeah, that's fine. Okay, there's something there. What is that? Oh, some, these are all the post spots are there. You can check. Now there is no point in checking. I have already checked and given. One of the plot was missing. That's why I had given that. That's okay. It doesn't matter. Okay, so we have this data, and I just run it because this is the first time when we run. It takes time, so I'm just running this data. It won't do anything now. The first thing is the algorithms don't work on text, so we have to convert it into integers. And how we do that, that I'll tell you. But before that, we need the labels and all. So in this example, we have string data. It has to be encoded into numbers. So label encoder is required. So sunny, overcast, and rainy would be 0 to 1. Hot, mild, and cold would again be 0 to 1. That is what testing classes we have to give. We can use scikit-learn to convert it, and that is what we are going to do. So first thing is we have to import the label encoder. The label encoder, we have done it earlier also. Import, okay, import label encoder. Okay, scikit we can use. So from sklearn, import pre-processing, you can import. Let me run it and see if the module is installed. Yeah, it is there. so you don't have to worry. Now I just have to create the label encoder. Create label encoder to label encoder LE is okay. L is equal to, this is what? This is play or not? It's okay. L is equal to pre-processing encoder. We have to call pre-processing dot. You can call encoder. It should be there. It is not here. Label encoder will be there. Round bracket. Since it is a function, you have to put a round bracket, and then you have to convert the data into vectors or integers or numbers, whatever you call. Okay, whatever you want to call, you can call that. Okay, so we can say whether is equal to, whether we already had, so we'll just have encoder, whether encoder is equal to L dot fit. You have to transform that. So fit transform you have to call. Fit transform is there. And in this we have to put the web data. That is why I changed the variable here, because weather was already there. So one by one we'll convert and see what happens. Now print. We can do one by one. Okay, so this is done. You can see 02, 012. The labels are automatically given. Now I can transform the other ones. So I have can use the same to fit the temperature and play. So we can have like I can just copy it and use for the time being. Okay. Transform the rest. Okay. So one was temp, so it is temp, that is for temperature. Now temp, here also something going on. Temp, okay. Now play or not, it was play. So I'll take it as a label, or I can have a class. I can put it as a class. Class is a reserve, but I'll take label. Here you have play. Here also you can have label. So we're just converting, transforming, and printing from 0 to 1. We have other converters also, transformers also, TF, IDF also we have other options, so we can use that, but this works fine, so no issues. Okay, now what we have to do is we have to combine the data. We have to zip the data. Okay, this is not a data frame or it is not a zip. These are all different values which are in different variables. So we have to zip that. So let's import numpy as np. We already have that. So combine the data. We have a zip function which we used earlier also, but we did not understand that time why it is required. So these are the features. These are the features. This one, weather and play. No, not play. Temperature. Play is your label. So okay, so we have to zip that. So features equal to zip. You can call it directly also. You don't need a numpy for that, but we have to convert it into list. So we'll convert it later. So weather, and it is weather encoder, yeah, and what we use temp encoder, and let's print and see. Okay, so let's run it. Okay, you don't see anything. Let's convert it into a list. So it's equal to list features print features, run it. You can see that it is now clubbed. Okay, so first is the weather. This is your temperature. Label for temperature. These are the labels actually, the vectors you can say. Now, three things we have to do, and I'll just put some text here. All right. So we have to generate the model. So you have to use the following steps. That is, create the Bayes classifier, fit the data set, and perform the prediction as we always do. All right. So we have to call the classifier. So from sklearn.iBias, we'll import Gaussian NB. Okay. And pre and post, we'll do that later. So just import import sklearn dot iBias. Okay, it is there. iBias from, sorry, have to import actually, classify from sklearn iBias import. Okay, this is working now. Gaussian NB. Gaussian. They're different NBs. Okay, iBias is NB. This is Gaussian formulation. It will be using now for prediction. We say true and false binary and giving no and yes, we can convert that also. Now we need the model. So model is equal to Gaussian. This we already have, so let me copy it from there itself. Okay. There should be no mistakes in writing. Okay, so you're calling the model. So, or you can say that create Gaussian classifier, create classifier object. As we have seen that we create the object of a class to call it. So this is Gaussian NB, and we have created the class. So of object of that class, and then we have to train the model. To train the model, we have to put the features and the label. So we can store it in a variable, or we can simply say model dot fit features, and we have used label. Okay, so far so good. Then you have to predict the, we'll just run it up till now. We'll predict it later. Let's run it and see. Gaussian NB created. Nothing much here. This is a single label we are talking about. We can have multiple labels also, and we'll see that also. Now, we have to predict the output, whether it is matching or not. predict the output. So let's do that. I can put pre, but that will be an issue. So what I can do is I can do it like this. Also, I can't put labels there. No and yes. I can have sunny and hot. So what should be the output? Okay, so we'll take it out from there. So 2 and 1 we are putting. So predict output model dot predict. We'll do that. So predicted is equal to model dot predict, and then I have to put in the data here. That is what we have to do, but we have to put two brackets here. Otherwise, it is not going to work. And this is 2. We know that is sunny, and 1 is hot. Mild we have not given. We can give mild also. Okay. Now I have to print the predicted value. Have the predicted value. Oh, sorry. No, I think it's okay. Okay, it's giving me something like this. So let us have the prediction P is equal to, we have what predicted, huh? I can have predicted, that is one only, but I have to get the value from there. So what is stored in it? Yeah, there is only one value, so it's okay. Now, can I play? The question is, can I play? And the answer has to come from here, pre. No more yes, pre, and we have to put p here. Okay, so let's run. Okay, can I play? No, you cannot play because the weather is sunny and hot. Okay, and suppose it is 0, 1. I'll have to change that. Yes, you can play because it is sunny. Sorry, it is mild and hot. Mild, sunny, and Kara. Let me see, sunny and okay. It is 2 is overcast. I think 2 is for sunny. 0 is for overcast. 1 is for rainy. Okay. So overcast. This is overcast. Overcast and hot. So you can play. So this is what it gives you. So you can easily find out. So this is a small data set, but it has only one label. That means only one. This one. Yes, no. Only one label is there. You can have multiple labels also, and then you can have the data, the coding accordingly. So let's see that. Multiple labels. Multiple labels. Again, the data set you can load, and this time I'm using a wine data set which is already there. So you can import the data like this. Some label there, scalar. You have to keep in mind that the syntax on net may not be correct. Load data using sklearn data corpus. There are many modules which have inbuilt data sets. These are all the benchmark data sets, so they are already available. What you have to do is you have to call them. Now, from sklearn, you have to import data set. That is a module you are calling data sets, and then you have to load that datasets dot load, and whatever line you can have. You can have some, there is some housing data set, there is some breast cancer data set which you can load. There are a lot of data sets which are benchmark data sets available, but you have to keep in mind one thing. If you search the net, you will find that it is a sklearn data set, and it is importing that, and then it says just simply load, but it doesn't work. That code doesn't work because sklearn module was updated, and the updated version we use sklearn import datasets and then datasets dot load. So let me see if it works, because if this has this is working. If it had again updated, then I would have to search again what happened. Okay, and find out the reason to load the data sets. Now you can see that the wine data set is loaded. You can see that this is the data, and the labels target you can see array, and then you have this class 1, class 2, 0, 1, 2. Okay, so we have the classes there, different classes. So you can see the data, and let's see, we'll work on it now. You can get let's print wine dot, we have target name, target names are there, and we have the feature names also. Oh, sorry, I'll just copy it and put it here. Wine dot feature names. Oops. Oh, okay, it's okay. Feature names, let me run it. Yeah, it is there. So you have the targets, class 0, 1, 2. Oh, I have to mute 1 minute. Okay. Is okay, fine. So this is the data you have, the features and the targets. You can see the features are different and the classes also 3 classes. So multi-label data sets also you can use, and we'll see the rest of the things are same normally. So you can have the shape. So to check the shape, we have the command shape. So find data shape. You can find the shape is required for classification. Okay, because if you're extracting the features, then it should be of the same rows. So now we have to split the data as we always do. Okay, split the data into training and testing set. Okay, so we already have a module for it. Again, we don't have to worry about that. Train test split we have to call from sklearn dot model selection import. Okay, now import main test. Okay, and sometimes fast that it doesn't come. Right, now you have to split the data already imported. Split the data. Now X train, Y train. So we have X train, Y train. You can have a small Y or what do you like? But let's have the test first. X train, X test, Y train, Y test. So this will be smaller one. We normally use it like this. Y test is equal to X train, X test, Y train, Y test. Okay. I'll use this train test split. Hmm, we have wine dot data, okay, and wine dot target. We have seen that wine dot target, that is the labels. Okay, we have to print give the test size, that is we normally split in into 30 70, 70 30, or 80 20. It depends. 80 for the training and 20 is for the testing set. Here we are doing 70 30, 70 for the training and 20 for the 30 for the testing. And then we have to fix the random seed, random state rather. Like let's put 20 22. Let me run it and see if it is working fine. Yeah, it is working fine. There may be some typing errors. That's why I always check. Let's print the data and see what is there in X test. This is the data we have in X test. Then we can check on X in. It was X test, right? Y train, Y test also we can have. Okay. Okay. Then let's see what we have in Y. Y test also we can check, but let's see. These are the labels. Print I test. These are again the labels. So X train and X test have the data in the ratio 70 to 30, and Y train and Y test have the labels again in the ratio 70 to 30. Keep in mind they are taken randomly. They are not taken sequentially, that you take say first 70 as a training and the rest as a testing. It is not like that. It is randomly picked without repetition. There's no repetition. So we do that. Oh, so many notifications I have which are not muted. I have to mute everything. Let I do that. Okay. I normally keep everything muted, but sometimes it just happens. Okay. Now, this we have done. We have split the data and we have seen the data also. Now we have to generate the model. We have the generate the model. So here you are. There's so many. They're so loud that this notification irritate sometimes. Okay. A lot of people are sleeping today. Generate the model. So we have to generate it now. So from Gaussian NB, we have to call it, and then we have to create an object, and then we have to fit to extract the features and then predict. Like we did earlier. So it is the same, but the only thing is now it is X train and Y train, because we have to pass on the labels. We already have it, so I'll just copy paste. It was already there with me, so just copy paste. Okay. Now Gaussian NP fit. You have to fit X train Y train, and then you just have to run it and see that what happens. This is the training part, and this is the testing part, prediction. So these are the labels you get, but how it makes sense that you have to see. But before that, let's calculate the accuracy. Okay, calculate. We have done NB earlier also, but this is a different example. We can test on any data set and see how it works, but you have to transform it and then it can work. Okay. Now you have the thing. You just have to run it, import test learning matrices, and then NB accuracy, score X test and Y predicted. This is the output, and X test is the label. So when we actually classify, what we get when we run a classifier on a data, what we get is a label. We get the labels, right? So we have got the labels here also. There's the output. You can see that in the predicted output we have 0, 0, 2, 0, 1, and so on. That is with the labels we have seen. These are the labels 0, 1, 2. So we have got the labels. Now this output, predicted output, if you put the testing set on it, the testing, not the labels, but the data. If you put the testing data to this label, what we get is the predicted output, right? And I've not printed actually. I've not put it in any variables. That's why I can't print it, but I can put it in a variable and see that what we get. Okay. Was in my voice, and I can put train test. Can have output equal to like this. I can see if otherwise I'll have to put output. Let me run it and show you. Let's run it and see what we get. I'll have to convert it into list, then only it will come. Otherwise, this is a classifier which has gone Gaussian NB. It has to be converted, and then only we can see. But what we get actually is the label only. So if you just predict it, so you get again the output of the data. Now I have to calculate the accuracy, and for that I have this accuracy score is 94%. That is quite good. And if you want to have it in 100 percentage, you can multiply that. But if this is okay, multiply by 100, you can get 94.44%, which is actually pretty good. Earlier, you can say that it wasn't the way we wanted, but this is good. NB, Bayes classifier is simple. To implement any classifier, you must have seen that it's very simple. Oh, sorry. To implement, and we have already seen the advantages and disadvantages. Still I'm putting here and just pasting. You can see that the advantages it has, simple approach is there. NIBAS has very low computation cost. When we say computation cost, it is the time consumed and the memory consumed. And then efficiency is okay. Low data set, it can work. It can work on a large data set also. And performance discrete responsive variable compared to the continuous variables. We have the discrete variable option also, not, and then we have multiple class predictions. Then text analysis problem, it solves that also. And when the assumption of independence holds, a non-biased classifier performs better than the rest of the learning algorithms. But the disadvantage is the assumption of independent feature. That is one disadvantage, that it assumes an independent feature. Okay, it is actually not possible, practically not possible to predict an independent feature practically, but it assumes that. Okay, so if there is no training tuple, then of a particular class, the accuracy is 0, will be not good, and model is unable to make predictions. Predictions will not be possible. So training tuple is required. Otherwise, there's nothing much can be done. It's a very simple classification algorithm, Bayes. You can try with others also with the same thing, and I can see the data is already loaded. We have the training set and the testing set. So if I change it, and let's see, let me try. I've not tried this one, but it will work, I'm sure. It is not a rocket science. I did not cover random forest. I just let me see if I can implement random forest on this. It should work, I'm sure, but still, let's see what I have to do. Ensemble. Yeah. So you have to change this. I can't paste. Okay, this much I cannot. Okay, have something like this. And number of estimators we have to give. So I'm not sure. I'll have to make some changes in number of estimators. I have given estimators for random forest. Random forest is a tree structure. So leaves, branches we have. So we have to give the estimators. So we have taken estimators as 100. I may have to reduce that. Okay. So here, rest of the thing I just have to change CLF classifier, random forest classifier. The rest is all the same. So let me run it and see if everything works. Not very sure because I'm not sure about the estimators. So it's working fine. You can see that. So let's see the accuracy. So random forest accuracy. It's very simple to implement. All the algorithms are very simple to implement. Yeah. Random forest. 94.44, it's almost the same. Is it taking? No, I think I have to change this. The classifier is fine. This is also fine. Let me change it. It may give me the same result sometimes. Accuracy looks like to be same. Could be same also. My test is okay. It is all same. 94.44% is the same as the previous one. Matters dot accuracy score. White test dot predicted. And let me see if I have applied this or not properly. Yeah, this is fine. Let me increase that. Estimators, I'm not sure if just increasing just like that. And how to see the features? Yeah, it has increased. You can see the number of estimators you increase, and this will increase. Number of trees you increase, branches you increase, and the accuracy will change. That is what we have a better option. It is okay. Stable. It is almost 96% because I don't think I can go for 20, 200. If there are 200 features, I can go through that also. But it is actually uh, estimation, n-graph approach, number of branches, something. It is stable. So 96 point. So there may not be more than 130 features. So number of estimators so it cannot be more than 30 or 140. It will still give me the same results. So you can see that. So it has changed a bit. With 100 estimators, it was the same as my bias, but we have changed it. That is the advantage we have with the random forest. So let's put a text here. In the previous applications, we did not do random forest. We did almost all the algorithms. Random forest was left. So in this case, we have done NP. We had done, but that was a different naive Bayes. This is a Gaussian naive Bayes. So we have done this, and now we have done random forest also. So on the data set you have, you can actually use any of the algorithms you have. Okay, so you have almost all the algorithms. Let me check. Oh, where is my GitHub? Here you are. Let me check the lab. The lab we did, or in the class, I think. I'll have to check. Okay, it's not the lab. The fourth or fifth, I think. Okay. We have to practice that also. Okay, yeah. In 10th, we had done the various ML algorithms. That is you had the logistic regression, decision tree, then K neighbors, then you have the linear discriminant analysis, then Gaussian NB, then SVM. Oh, this was not done. Gaussian NB we had done earlier also. Yeah. We left random forest that time. That is in lab AML 10, which you have to practice also. So we have now 3. We have to implement that, and you have to share with me also. This I have to first of all save. I have not used dataset from anywhere. I just loaded from sklearn, so it should not be a problem for you to upload the data. Okay, so let me save it. Save a copy on GitHub. Okay. You already have the link with you. You just go to the root AIML, and we have lab 6. We have lab 6. We have to do AIML 10, 11, and lab 6. You just have to put them in a notebook, and you can share with me, and you can check with other data sets. Let me see if I have a list of the data set. We can see. I'll share the link possible. It's called toy dataset. Yes, it has the Boston, iris, diabetes, digits, line, linear. Okay, Boston. There's some deprecated. That means they don't exist. The Boston is not there anymore. So you can upload these data sets you have. I'll just share the link with you. It's always better to go to the manuals. I'll just put the link here also. Sets. These are the scikit, that is sklearn. So you can have that. I'll just update the file at GitHub. Okay. Let me share this with you. There are a lot of people missing today. It's okay. I've shared the link. This has not gone in public chat. Has it? No. Okay. I'll put it here. All right. I think, yeah, it's shared now. I'll put it with your WhatsApp group also. And we can discuss few things later, but let's do it first.
Unknown caller.